I don't remember if we got the back of this board. No, we don't. Okay, I'm going to use this. Okay, so. And people did fairly well on this. Okay. So it was f of g of x equals, what do I do? Square root of 1 over f. So what's f of x and what's g of x? Well, in the expression f of g of x, what's the first thing that you're going to evaluate? If I give you the value of x, you're going to figure 1 over x. I say x is 2, you're going to get 1/2, right? So you're going to start by substituting x into the 1 over x function. That's your g of x function. So g of x is 1 over x. And then what do you do with that value? Okay, you get 1/2, you're going to take its square root, right? Well, so f of x is square root function. Okay, so it's pretty straightforward, but you're having to turn around what you learned to do. Okay, with creating composites, you want to check this. F of g of x is the square root of g of x, because assuming f of x is a square root of x, then f of g of x would be the square root of g of x. But g of x is 1 over x. Okay. Now, if you take a calculus class and take a pre-calculus, there's a very good chance, as I said, that you're going to at least do an applied calculus course. Okay. Then you're going to get to this thing called the chain rule, which is the first pretty confusing thing you get in calculus. Okay. Because you have to do this. Okay. If we ask you to take the derivative, and of course you don't know yet what that is unless you've had some calculus. If I ask you to take the derivative of the square root of 1 over x, then the chain rule says that you have to be able, but in order to do the chain rule, you have to be able to decompose this. So the formula for the chain rule, I'll just write it down. You don't even bother writing this down because you won't know what it means, but okay. For this prime thing, telling you more than you want to know, but since we just did rates of change, okay. This prime thing is the most important operation in first semester calculus. It's just the rate of change. So this is the rate of change of f of g of x. Just a way of calculating without having to do 2 points to do an average rate of change. And this is the rate of change of g of x. And this is the rate of change of x. Evaluate it whatever g of x it is. And you don't have to remember any of that. But I'm just mentioning it because it pulls together the concept of rate of change, the concept of decomposing composite function. Okay? It's very important. And if you know how to decompose a composite function, and if you just follow that rule, you're going to be able to do it. Because the rules for doing the derivatives are simple. Okay? Right, sometimes they're not quite as simple, but it's not until you get to the chain rule, the rules for derivatives get to be kind of challenging. It's essential. Most of the functions that model things in the real world are composite functions. And if you want to find their rates of change, which is very important, have to be able to do this. So this is preparation for one of the toughest things in first semester calculus, okay? And then what we're doing here, this is pre-calculus, trying to prepare you for some sort of a calculus course, like calculus or engineering calculus. You want to go into engineering or sciences, you know, physics, chemistry, and stuff. You need that. So there it is. And it's maybe the biggest connection you'll find in calculus in this course. You've seen it already in chapter 1. All right. Again, you don't have to remember what I just said about the calculus, just telling you with a little bit of detail why we're studying this. Okay.